Alright, hello everybody. My name is Mike Watts, and I'm here to tell you a little bit about the MIPS ISA, or Instruction Set Architecture, specifically registers, why they exist, and how they can be used. So I'm sure most of you are familiar with some sort of object-oriented programming like C or C++ or Java, where you use variables to store values or strings or characters. In assembly language, there's no variables, so we use registers instead. They provide you a way to store information. So one of the benefits of using registers are directly in the hardware, so they are very fast. There's a little illustration that shows you kind of the hierarchy of different types of memory, and register files are on the very high end as far as speed. Unfortunately, they're also the highest end on cost as well, so that's one thing to keep in mind. Which kind of brings us to one of the drawbacks of registers. Our registers are directly in hardware, therefore there are a predetermined number of them, 32 to be exact. So each MIPS register is 32 bits wide, and just another piece of information, groups of 32 bits are called words in MIPS. So different registers have different uses. Some registers only save their value in the current function, while others are available outside the function. This is similar to scope. So if it's globally defined or if it's within a specific function. And also, just one thing to keep in mind, registers are preceded by a $sign. That's kind of like their code in assembly language. And when you program in assembly language, you can either use one of two formats for addressing the register name. Either the register name itself, so it would be like $T1 or register T1. Or you can call it by its register number directly. So for example, register T1, temporary 1, would be register 9 or $9. And we'll go into that a little bit in more depth in a little bit. So like I said, there's only 32 general purpose registers. So to keep that in mind, your MIPS code must be carefully put together to efficiently use these registers. So it's a good thing for you to know what each register does and what you can use it for. So I'm just going to kind of step through each of the groups of registers, and then we'll kind of give you the big picture at the end. So first off is the 0 register. Its name is the word 0 spelled out, and its number is 0 itself. You can use it as a constant 0 anytime you want. It's built into the hardware. Next up is the AT register, or number 1. It's reserved for the assembler, and the assembler uses this as a temporary value. Again, when it says reserved, that means that you cannot change it. And you can't change the 0 register either. Next up are V0 through V1, or registers 2 through 3. These are your expression, evaluation, and function results. Next up, we have our function arguments, or registers A0 through A3, registers 4 through 7. Those are the numbers. Like I said, these are used for function arguments. Next up, you have the temporary values. So registers names T0 through T7, or register numbers 8 through 15. Again, these are temporary values. The caller saves these, and the callee can clobber these. Next up, we have our saved temporary values. So that's names S0 through S7. The numbers are register number 16 through 23. Again, it's kind of the reverse of the regular temporaries. The callee saves these, and the caller can clobber. And then we actually have the continuation of the temporaries split up for some reason, the last two. So those names are T8 and T9, numbers register number 24 and 25. Again, these are temporaries, and the caller caller saves, and the callee can clobber these. After that, we have registers named K0 and K1. The numbers are 26 and 27. These are reserved for the operating system kernel. These are also used for exception returns sometimes. After that, we have the global pointer, or register GP, number 28. This is the pointer to the global area. After that, we have the stack pointer, or register SP, number 29. And this tells you where you're located at in the stack at that given moment. After that, you have the frame pointer, or register name FP, number 30. And finally, the last register is the return address register, or RA, number 31. So that kind of gives you a look into each of the registers and how they can be used. I recommend that you kind of get familiar with these so that when you're writing your programs you don't have to reference the table. But for now, I'll go ahead and show you a table. This is the final register table, and it's broken down by register number, and then the next column it shows the register name, and then after that it gives you a little bit of a description. The ones with the red box around them that are kind of shaded in are ones that you cannot edit. You or your program cannot edit these. Past that, they kind of group them together by color just so you can see what groups go with what. Again, it's the V registers first, and then the function arguments, then the temporary values. And in between the temporary values, the first 8 are on registers 8 through 15, and then the saved temporaries are next on registers 16 through 23, and then you have a few more temporaries after that, registers 24 and 25. So that kind of gives you a breakdown. I would recommend that you have this table until you get used to it, and then after that, hopefully you kind of get to the point where it just kind of comes as second nature. So again, my name is Mike Watts, and thanks for tuning in.